Okay, so today we want to talk about limits that involve infinity. Last week we kind of wrapped up limits where they would equal a number, right? Whether an open circle or a closed circle, and different types of left-hand and right-hand limits. But a lot of times we can get some information and really describe our function kind of using the infinity symbol. Now, for all of these, you also, if the answer is going to be infinity or negative infinity, it would still be okay to say does not exist, but it's not going to help you understand the function. So we like to see them like this sometimes. So it kind of means the same thing it always did. That this is number one. The limit of f of x as x approaches 3 from the left is positive infinity. So in terms of a graph, as we approach the line x equals 3, from the left, we are going to go up to positive infinity. So for that one, so as we approach, again, you have this line here you can think of. Now, what do you think is going to happen at 3? Any ideas? Yeah, we're going to have a vertical asymptote. So I would go ahead and graph that here. Right? If your output is going to be infinity as you approach a fixed number, we're going to see that's going to be a vertical asymptote. I just think it's a nice thing to sketch the graph just to kind of see what's happening in this region. So this says as we approach 3 from the left, it goes to infinity. So I know that at some point it's going to go up like that. Right? I have no idea what's happening for the rest of this function, but I know that that occurs. And this one tells us the limit of f of x as x approaches 3 from the right is negative infinity, which would be going down. Something like that. So that would be what that tells us. So what that shows us here, because we have, if either side goes to infinity, we're going to have a vertical asymptote. Okay, so if the limit as x approaches a from the left of f of x, or the limit of f of x as x approaches a from the right, or if the limit of f of x as x approaches a, right? Any of them, any limit as we approach a from the left, from the right, from both sides, goes to a positive infinity or negative infinity, then we have a vertical asymptote at x equals a, right? Whatever that limit was going to. So if you ever get a limit that goes to a finite number that goes to infinity or negative infinity, we just found a vertical asymptote. Right? That's a way to confirm. So in this case, for example 1, we have a vertical asymptote there. And if you really think about it, there's really no way that this could happen and you not have a vertical asymptote, right? Because we just are going to infinity there. And then one last point here on example 1 is if you were asked what's the limit of f of x as x approaches 3, right? Well, because the left-hand side is positive infinity and the right-hand side is negative infinity, they are not the same. So we'd say that this limit does not exist. So for our second problem here, we're told that the limit of f of x as x approaches infinity is equal to 2. Okay, well, so what's this mean? As x approaches infinity. That's kind of like the old end behavior stuff we talked about in pre-calc, right? What happens to y as x approaches infinity? This is just a kind of nicer, more compact way to write it. So what this is telling us in terms of our graph is that we have some, as we go out to the right, as we approach infinity, the y value is going to approach 2. Now, it doesn't tell us anything about what happens near the function, but we know that it could look like that, right? Just go out along that infinity, or it could be above it. You could cross over it. It doesn't really matter. But out at the ends of the function, the end behavior is that the output's going to get close to 2. It's going to approach 2. So in this case, we would say that we have a horizontal asymptote at y equals 2 for that case. Okay, now in general, if the limit as x goes to negative infinity of f of x equals a constant, or the limit as x approaches infinity of f of x equals a constant, I guess I could put plus infinity also, then y equals k is a horizontal end behavior asymptote. Which horizontal asymptotes are one type of end behavior. So as we do that, so I probably want to jot that down somewhere. And as we're going to see here, sometimes if this limit equals a number and this one equals a different number, we could have two different end behaviors, right? One to the right, one to the left. We haven't done a ton of functions probably in the past where that happens, but there are types where that can occur. Okay, so again, if the limit of f of x as x approaches negative infinity is equal to k, or the limit of f of x as x approaches positive infinity is equal to k, then y equals to k is a horizontal end behavior asymptote. And that's what we had in example 2 there. Okay, so here are just 4 more limits we want to take a look at and see if we can use infinity as any of our answers. Just kind of review the process here. So now as we look at all of these though, we're still going to go back to our first step is going to be to look for, is it indeterminate, and try direct substitution. So here if we try direct substitution, we're going to get 1 over 0, which is just undefined. It's not indeterminate, it's a 1 on top. So here you could say does not exist. That would you'd be correct. But let's investigate to see what the left and right hand limits look like. So say they both go to infinity, then maybe we'd want to say it goes to infinity instead, or negative infinity. That would be additional information, right? You could have this, or you could have this, or if you get both sides, you could tell what it's going to look like. So if I want to find the left hand limit as x approaches 1 of 1 over x minus 1, what I want to think about is just, I'm going to make a little table, and I might get the numbers, or I might just kind of get the idea of the numbers. So with this, I'm going to approach this from the left. I didn't put that there. So as we approach it from the left, a value to the left would be like 0.9, correct? And here we could take advantage of how decimals work, but we'd still have 1 on top, and we'd get negative 0.1 on bottom, right? Which would be negative 10. It's a negative number. If we even did 0.99, so we get even closer, right? Well, that would give you 0.01 negative on bottom, wouldn't it? So 1 divided by negative 1/100th would be negative 100. So what do you think is going to happen as we approach 1 from the left? What do these seem to be doing? They're going smaller and smaller, right? So the smaller the number gets on bottom, right, it's going to be closer and closer to 0, but it's going to make the output a bigger and bigger, a more negative number all the time. So it would approach negative infinity. So that would tell us that as we approach 1 from the left, that it's going to be going down, the function. Right? If we look at from the right, of 1 over x minus 1. Well, there we're going to try numbers a little bit bigger than 1, but that's going to make our denominator positive, isn't it? So 1 divided by a small positive number, and then even smaller. So we could try like 1.1, and that gives you 1 divided by 0.1, which is 10. Or 1.01, which is 1 divided by 1.01, which is 100. So as we approach 1, this is going to approach positive infinity. So the left-hand limit at 1 is negative infinity. The right hand is positive infinity. Hopefully you knew that that's kind of what that graph looked like. It's just an old hyperbola, right? So would the two-sided limit exist? No, the two-sided limit does not exist. But now if both of these would have, say, be positive infinity, then it would, correct? Okay, good. Number 2, I just wanted to review. This one we'll try to substitute, right? And you'll get 4 minus 2 minus 2, which is 0. And then 4 minus 4, which is 0. So that's indeterminate, correct? So that doesn't mean probably infinity is not going to be our answer. We're going to have to do what we did last week. And that would be to try to simplify this. And that will be x minus 2, x plus 1, x minus 2, x plus 2. Those cancel. Right? So then our limit would be, by direct substitution, 3/4. This one, number 3, a little different here. This is the limit as x approaches infinity, and we just have to kind of figure out how to do that. Okay, for our third one here, this is a limit as x approaches infinity. If you're ever asked about end behavior, we'll see more of this next class period, you probably want to take the limit as x approaches infinity. Just see what happens. Now in this case, just kind of reason our way through it. This is a 5 on top, which is just a constant. This is going to be infinity squared, which is not really a number, but it's going to be big, right? And if you think it's large, it's going to get even larger as we approach infinity. So this is 5 divided by some giant, huge number. So what's it going to approach? 0. It's going to approach 0. Does that make sense to everybody? Like if you could make a table, if you keep putting bigger and bigger numbers in for x, it's going to get to be a smaller and smaller fraction. So it's going to approach 0. So that limits 0, and that means that there is a horizontal asymptote at y equals 0 for that end behavior asymptote. This last one here is almost the same as number 1, but I went ahead and squared the bottom. What do you think is going to happen when I square the bottom? It's going to take these little bitty numbers and it's going to make them all positive, correct? So what we're going to have here, now again, we'll try direct substitution. We do get 1 divided by 0, which tells us we could just say does not exist and it would be correct, right? But let's find more information. As we look at this, if we do the two-sided limits, if you do 5 from the left of 1 over x minus 5 squared, well, even though you're putting it, even though the 4.9 minus 5 would be negative, you're squaring it, correct? And then we see as we get closer and closer to 5, the denominator is going to get smaller and smaller, right? And 1 divided by a really small number is a big number, right? Is that just the same thing that we did over here? So you could argue it the same way, but that would be positive infinity here. And then the left-hand limit would also be positive infinity, right? You have 1 divided by increasingly smaller and smaller numbers. So if both of the left and the right side both go to the same thing, could we say that for this up here also? Yeah, so we could have said this is equal to positive infinity. Meaning that as this graph, as we get close to 5, there is going to be a vertical asymptote, and it's going to look something like that. Inverse squared function is what you call that. But where they both go up to infinity, so in that case we can actually say the two-sided limit is positive